right, lovelies, welcome to my walkthrough for Recitation 5, question 1. So I drew the diagram just down here so I can more easily point to it. So we're going to be using this equation for each of the 4 points acting on this. So I thought the first thing we should try to look for is this R value, because that's going to be the same. The distance to each of these points is going to be the same for each of the points. So really what I did is we're looking for this length here, which is half of the diagonal of this square. So it's just going to be the square root of a squared plus a squared, and then 1/2 of it. So that's what it is here, 1/2 square root a squared plus a squared. Simplified that down and simplified it down again. Just took this root 2, put it on top of that 1/2, and square root of the a squared. So this is our R value. Then I started looking at this R hat, because this is what's also going to be different for each of the points. But really, if we just break it down, the R vector going from this point to any of these points is going to be the magnitude of that times this unit vector R hat. Because if we multiply by the magnitude, that's going to get us back there. So if we're trying to find this R hat, we're going to do the vector, the full vector from here to here, divided by the magnitude. And we already have that our magnitude of R is the square root of 2 over 2 times A. So now let's start for each of the points. I'm going to start with what I've called point 1 up here. So what it does is we're going to use this whole equation. It's going to be KE, and it's a positive charge, so it's just going to be Q over our R squared, which we said R was root 2 over 2 times A. So our R squared is going to be, if we just square this, so R squared, it's going to be 2 over 4 A squared, which is just going to be A squared over 2, because that's just 1/2. So that's going to be A squared over 2. And that's going to be times whatever we determine this R hat to be. So if we're looking to go to this charge from here, we're going to go up in the J direction, positive J, but negative X, right? So this negative X, we're going to be going 1/2 of A. So that's going to be A over 2. And remember, we're still dividing by this magnitude R over root 2 over 2 times A. And that is in the negative I direction, right? And now it's the same thing, plus, because we're going positive, but we're still going up A over 2 in the J direction. So it's going to be plus A over 2 all over root 2 over 2A in the J direction. And this is I hat and J hat. So I just forgot the hats. But that's, again, these unit vectors. So this is the electric field on this point caused by this charge. And now I'm just going to repeat that for each of these 4 points. All right, so I just went ahead and wrote out all the different things for these different points. For point 2, it's a positive charge with that same radius. And the magnitudes in each direction, the only thing that's going to be changing is the signs of each of these, because they're all going to be going up and over the same direction, and they still all have that same magnitude R. So it's going positive I and positive J to get to point 2, and then we're going negative I and negative J to get to point 3. So that's our negative, and that's a negative charge as well. And then we have our negative charge with point 4, and that's going in the positive I and negative J. So that's just all I've written out here, and now I'm just going to simplify this real quick, because what we're going to do is inevitably we're just going to sum all of these up, because that's all we're doing. We're just summing all of this, and that's why we're breaking it into the directions so that we can more easily add them together. So I'm just going to factor out, because obviously this is the same for all of them, except for the signs. I'm going to factor that out and simplify all of this. All right, so this is kind of what it looks like factored and simplified out. So all I did is I canceled the A on the top and A on the bottom, because it's A divided by A, and then I multiplied the top and bottom by 2. And I did that for all of them because they're all going to be the same. So it all ends up being just 1 over root 2 times whatever it is. Then I distributed, since I was factoring out just the positive KE, and I also multiplied top and bottom by 2 on this one to get rid of that fraction in the denominator. Since I was factoring out that KE 2Q over A squared, this negative now has to go in with this. So we have a positive times as a negative there, positive there, positive there, positive there is a negative and a negative, so that's our positive there. Then a negative and another negative, that's a positive there. Negative and positive gives a negative, and a negative and a negative gives a positive. So now we have all this, and we have a minus I hat, plus I hat, so those are going to cancel. Then a plus I hat, minus I hat, those are going to cancel. So then finally we're left with KE 2Q over A squared. That definitely looks like a Q. My handwriting's getting worse. And that's all times 1, 2, 3, 4, 4 J hat over root 2. Now we can pull this out, and we can multiply this coefficient times all of this. This is going to give us our KE 8Q over root 2A squared, and that's all times J hat. And now obviously I've been avoiding breaking up this KE, but now we can break it up. And that's just going to be the KE is the 1 over 4 pi epsilon naught. And now I'm just going to multiply all of that in over here. So that's going to be 1 over 4 pi epsilon naught. It's not 1, it's going to be, that's our 8Q J hat. And also in the denominator is root 2A squared. So what we can do, we can cancel this, because divide by 4, that's going to leave 2 on the top. And just because I hate radicals in the denominator, I'm just going to multiply by root 2 over 2, which is just 1. And that's going to give us, so it's going to be 2 root 2 Q J hat over pi epsilon naught 2A squared. Now these 2's are going to cancel as well. That's going to give us our answer of root 2 over pi epsilon naught times Q over A squared, all times J hat. And the only other thing I neglected to mention with this J hat is that since this is a positive charge and the resulting force is going to be pushing this way, or the resulting field is going to be that way, and this charge, the resulting field is going to be that way, because again, they go away from positive. And since this is negative, the resulting field. And then one thing I did forget to mention with this J hat is that since these positive charges, since these are positive charges, it's going to go away from that positive charge. And since this is also a positive charge, it's going to go away from that positive charge. And then since this is negative, it's going to go towards that negative charge for these fields, and the same thing over here. So we can see that these x's kind of cancel out as they did, but also this J hat, this y direction, it's going to be straight down. It's going to be negative. So our final answer is going to be root 2 over pi epsilon naught Q over A squared times negative J hat. So this is our answer, and we're going to scroll. We see that Kudu changed my answer when I submitted it, but this is our correct answer right here. All right, and again, thank you guys so much for watching. Let me know if you have any questions about anything. If I talk too fast, if I wrote too messy, are all very valid possibilities. And let me know if you want me to make a video about any other questions.